Hi everyone and welcome back to Grade 12 Math with Mr. Simons. Today's lesson we're looking at trigonometry and we're looking at identity and general solution problems, right? So I've chosen the IEB November 2020 exam paper and the November 2021 paper. So determining general solution and solving identities. Right, so let's look at the question. Right, so November 2020, question 4, they say determine a general solution for cos theta minus sin theta equals 0 for 3 marks. B, number 1, they said prove the identity sin 2 theta plus cos 2 theta plus 1 divided by cos 2 theta must equal 2 cos theta minus sin theta for 4 marks. And then 2, write down all the values for theta in the interval 0 to 180, so quadrant 1 and 2, for which the identity is not valid. Then from the November 2021 paper, question 8. A, they say solve for x, correct to one decimal place in a given interval. So sin 3x equal negative 3 over 4 for x element of negative 92, 0. So we want our answers in that interval. B, determine a general solution for tan x equals sin 2x if sin x is not equal to 0, and that there is 7 marks. Right, so as I explained to you previously, you can pause the video here, attempt to answer and see how far you got. Look at the mark allocation as I'm working through it and see where you would have gotten marks, where you've lost marks, and then go practice that till you are able to master and do it correctly. Alright, so let's go to the first solution and work together through it. So, determine a general solution for cos theta minus sin theta equals 0. So first, if I take cos theta across, this would become negative sin theta equal negative cos theta. Right? Then I'm going to divide by cos theta on both sides. So if I divide by negative cos and negative cos, cos theta divided by cos theta equal 1. Sin theta divided by cos theta gives me tan theta. So tan theta equal 1. My reference angle, if I say shift tan 1, I would get 45 degrees. So theta equal 45 degrees plus k times 180 degrees. Alright. 1 mark for tan theta equal to 1. 2 marks for specifying that theta equal 45 plus k 180. That is in first quadrant. Right. So there's my 3 marks. Let's go to the second problem. They say prove the identity sin 2 theta plus cos 2 theta plus 1 over cos 2 theta equal 2 cos theta minus sin theta. So first I need to understand if I see plus 1, then the cos double angle must be expanded to in such a way that it will cancel the 1. Number 2, if I see 2 terms there, cos theta minus sin theta, means here I'm working with factorization. So there, sin 2 theta can only be expressed as 2 sin theta cos theta if we expand it using double angles. Cos 2 theta becomes 2 cos squared theta minus 1 plus 1. So I've chosen not 1 minus 2 sin squared, but that minus 1 because the minus 1 plus 1 will cancel. The bottom 2 theta to factorize to cos and sin, I use difference of 2 squares, so therefore becomes cos squared theta minus sin squared theta. So on the top that becomes 2 sin theta cos theta plus 2 cos squared theta minus 1 plus 1 cancels. Right, now if we take out the common factor, I assume then purple you can see I have a cos theta on either side of the plus sign. Right, so if I take out the 2 with the cos theta, I'm left with sin theta plus 1 cos theta that's left there. The bottom difference of 2 squares, that becomes cos theta times cos theta, sin theta times sin theta, but one is negative and the other one is positive. So there sin theta plus cos theta cancels with cos theta plus sin theta. Right, so now I have 2 cos theta left, cos theta minus sin theta, and that looks the same as my right hand side, so therefore equals my right hand side. Number 2, they say write down the values for theta in interval for which the identity is not valid. So from grade 9, we should still remember that when we divide by a 0, this whole expression will become undefined on my equation. So therefore, I'm looking at where's cos 2 theta equal to 0. Right, so we should know the cos of 90 is 0 and the cos of 270 is 0. So therefore, 2 times 45 gives me 90. So cos of 90 equals 0. 2 times 135 gives me 270, and the cos of 270 equals 0. Therefore, my answer is 45 and 135. Right, so there we gave you 1 mark for the top 2 cos squared minus 1, and another mark for cos squared minus sine squared. 1 mark here on the top for taking out the common factor, and another mark for factorizing at the bottom. That's your 4 marks, and here's my 2 marks. I hope you follow and understand. Right, let's look at the next question. Right, now November 2021, they say question 8, solve for x correct to 1 decimal place in the given interval. Right, so sine 3x equal negative 3 over 4 for x. Right, now because it's a negative angle, I summated the reference angle with the negative. So shift sign minus 3 over 4 gives me negative 48,9. Could have said sine 3x, shift sine 3x, and put positive 3 over 4, then there you would have 48,59 or 48,6 for 1 decimal place. But yeah, here I'm working with negative. So sine is negative in quadrant 4 and quadrant 3. So in quadrant 4, 3x would equal negative 48,59 plus k times 360. Remember, k is the element of integers. In quadrant 3, 3x would equal 180 minus minus, or remember it's 180 plus naturally, minus minus 48,59 plus k times 360, and k a element of integers. There, divide everything by 3, so 3x divided by 3 minus 48,59 divided by 3, k360 divided by 3, right, same here on the other side. So x there equal negative 16,2 plus k120, k element of integers. So other side here, if we divide by 3, x there equals 76,2 plus k times 120, k element of integers. So here, if I make k equal to 0, that becomes 120 times 0, so therefore my answer is negative 16,2. Here, if I make k 0, it will give me 76,2. It won't fall in that range. If I make it minus 1, minus 120 plus 76,2 gives me negative 48,3, and that answer falls within that range. So therefore, x equal negative 16,2 or negative 48,3 degrees. So there's my mark allocation, 4th quadrant. There's simplifying and getting the correct answer. That's my 4 marks. Alright, so I hope we're together. I hope you follow. Let's go to the next paper. November 2021, sorry, same paper, question 8. Determine a general solution for tan x equals sine 2x if sine x not equal to 0. So tan, we assume you remember, sine over cos x, 1 mark. Sine 2x can only become 2 sine x cos x, so 1 mark for that. Multiply the denominator away, so cos x goes away, so that becomes cos x times cos x gives me cos squared x. So that becomes 2 sine x cos squared x. Right, if I take everything over, so sine x, bring it over and everything's on the same side, that would read 2 sine x cos squared x minus sine x. Take out the common factor there, you can see in red is sine x. Right, and I'm left with 2 cos squared x minus 1. Right, but they said where sine x not equal to 0, so we're not worried with sine x equal to 0, so 2 cos squared x minus 1, right, can be written as cos 2x. It becomes a double angle. So therefore cos 2x equals 0, right, shift cos 0 gives me a reference angle of 90 degrees, right, so I can say 2x equal plus minus 90 degrees plus k times 360 in quadrant 1, k element of integers, and there if I divide by 2, 90 divided by 2 would give me 45, 360 divided by 2 gives me 180. Right, and as you can see, 1 mark here for sin x equal to cos squared x, correct multiplication, 1 mark for factors there, 1 mark there for writing it as a double angle, and 2 marks for my final answer. Right, so I hope you enjoyed the lesson. Wish you nothing but the best. God bless. Bye.